Hey, need to flip some cards? How about horizontally? And what if you only want to flip them to a specific side while the mouse hovers? Or flip them up when being clicked and held, then flip back when your player releases their button again? Or just keep on flipping ad infinitum no matter what the player's input looks like? Or maybe have a whole bunch of them and have an easy way to customize them, then trigger them as a group. Hi and welcome. In this tutorial, I'm walking you through how to create a flipping component you can attach to anything on your UI and control its behavior with some super handy dropdowns and an animation curve. This way, you can build this once and reuse it across projects, or just at different points inside your current project. I've had this one in my own toolbox for about a year, just polished up the code for this tutorial. By changing the animation curve, you can fine-tune how exactly you want your card to be revealed, from snappy to bouncy or just plain linearly. I've been planning this as an entry in a series all about UI juice behaviors, so please, if you enjoy it and want to see more like this, give this video a thumbs up and leave a comment which effect you'd like to see next, and it doesn't have to be any of the ones on screen right now. You can find the scripts for this over at my Ko-fi, link is in the pinned comment. Let's dive in. We begin in the inspector. Create a new empty child object on your canvas and call it card. Size it roughly to how you want your card to look like later. Mine sits at 540 by 830. Create a child object to it and call it card contents. It needs to fill the full area of the parent object. To do so, click on the anchoring menu, hold Shift and Alt, and click on the bottom right entry. Next up are two child images, one for the front and one for the back. Drag your respective images into the field and make sure to check Preserve Aspect Ratio or your images are likely to end up squished. Just like with the parent, they need to fill the full space of their container. If there's a lot of space at any of the sides, change the size of the main card object to make it fit. You can see the actual size of your images when you open the preview at the bottom of the inspector. Then switch over to the layout properties. This mini step is purely optional, but if you are looking for a good drop shadow effect, UIFX Drop Shadow by Chocolate Dinosaur is a great one. I attach it to both images to give them a bit of depth. The way this system is going to work is that, depending on which card face should be displayed, the card content child object gets sized down to 0 on the chosen axis. Then either the front or back gets disabled and the other one enabled. Afterwards, the card content gets scaled back up to 1 again. You can create a flipping effect by rotating around the Y-axis as well, but doing it this way will give you a lot more fine control for slight squash and stretch effects, which will add a lot more personality to your UI. If you made any changes to the scale or rotation, set everything back to 1 again. Lastly, go back to the main card object and add an image component to it. Which image you'll use here doesn't really matter. I will just go with a default graphic. Set it to transparent by reducing the alpha to 0. This is required because the component we create requires some kind of graphic to notice clicks and interactions. By attaching an image like this, we make sure this can be achieved. We are now done with the setup in the editor. Now let's head up over to the code side of this. In the inspector, you've seen the dropdowns for controls, so let's start with the enums first. The vast majority of the enums I use are in a shared Juicy enum class, which my library of juice effects works with. Only enums specific to the effect get added to that effects class. For this flip animation, we use one for the mouse button to control which button should trigger the effect, an enum for the juice interaction type, which handles on which kind of interaction the effect should trigger, the juice click behavior, which is useful for any effect that works with two sides to switch between, like our card, and the juice start behavior, which will handle how the effect will behave at start. There is a juice pivot in this class as well, but we won't use it in this tutorial and effect. I also had a very short ISJuicy interface the main effect will inherit from. This comes in useful for things like the mass trigger controller I show at the end of the script, and makes sure all effects of this library can be triggered without needing any knowledge about the effect itself. Juicy Flip is the main class for the effect, and it starts with a whole lot of interfaces, which will enable us to interact with the card in some way. I-pointer click handler, I-pointer enter handler, I-pointer exit handler, I-pointer down handler, and I-pointer up handler. These are what allow our card to react to mouse interactions, and we'll need all of them because we want to support quite a few different ways to trigger the flip. The last one in this list is the custom-made ISGUI. At this point, everything is underlined in red because you haven't implemented any of the required classes yet. We will tackle those one after the other in a moment. We also have two enums, yes, even more enums, living right inside this class because they are tailored to this specific effect. Flip direction is private since it only ever needs to be used here and inside a serialized field, horizontal or vertical, depending on which axis you want the card to flip to. Card side is public though, because other scripts might need to know or set which side is currently showing. Moving into the inspector setup. The header groups keep things neat and tidy. Under setup, we just need references to the card's front and back game objects. The child game objects only attribute is optional and an Odin Inspector specific one, so if you don't use Odin, do not add this. It gives us a nice dropdown, so we don't accidentally drag in something unrelated. This is especially useful when you need to make changes to an object, but want to make sure only child objects are referenced. If you accidentally add a reference outside of the child objects of this script, you will get a handy warning. Animation controls covers the flip duration with a range attribute, because you really don't want this to go slow. Up to half a second is typically good enough and makes your UI feel responsive instead of just slow. An animation curve is going to be used for easing, which means it will control how fast or dramatic certain effects are going to play out. In this class, it handles the way the card's children gets transformed. The continuous flip delay has a rather arcane-looking show-if attribute, which once again comes from Odin Inspector, and you can just simply remove it if you don't have it installed. This makes sure this entry only shows up in the inspector when interactable is set to false, since that's the only situation where it actually applies, at least in my own projects. The last entry for this block is the start behavior, which uses the juice start behavior enum from our shared file. Flip controls is where the more interesting set of configurations live. We have a toggle for whether this card is interactable at all, which mouse button triggers it, which direction it flips, how it reacts to interactions like click, hover, hold, and so on, and which side to start on. Down means the face of the card faces a table in this example. The current card side shown can be accessed from outside if needed. We store the card side that was showing before the player hovered, so we can flip back to it when the cursor leaves. The next block is for the flipping functionality. Two coroutine references hold a coroutine for a single flip, one for the continuous flipping loop. A wait for seconds for the delay between loops, a bool to track if we are currently mid-flip, the current scale of the card since we need to track that during the animation, and a flag to stop the endless loop when needed. At the end of all this initial setup live the three events you can have other scripts subscribe to: on flipped face up, on flipped face down, and on flip complete. These are for anything outside this script that might want to react, like playing a sound, triggering another animation, or whatever else your project needs. Onwards to the methods. In Awake, we initialize our wait for seconds and set the initial phase of the card. Set initial phase sets the current card side shown, resets the scale to 1, then activates the correct side while deactivating the other. This is also a public method, so it can be called from outside if needed. In start, we check our start behavior. If it is set to play once, we flip to the opposite side immediately. If it is set to play continuous, we kick off the continuous flip loop. And of course, if it is don't play on start, we do nothing. On disable, make sure any continuous flipping gets stopped cleanly. Trigger effect is the method from the ISGUI interface, and once you add this, the respective interface won't be underlined in red anymore. Depending on whether the card is interactable, it either flips to the opposite side or starts the continuous flip. This is also where you can customize what you want to happen when this script is called from outside. Flip to opposite and start continuous flip are just the styles I typically default to. The 3 public flip methods are pretty short. If you are unfamiliar with the way I wrote these, this is what they look like in longer form. After writing a full book with tons of code, the way I write my code day to day has changed quite a bit, and I've become fond of shorter versions. Flip to opposite just calls start flip with whatever the opposite of the current side is. We'll come to that method once we reach the helper section for the script. Flip to lets you specify a side directly, and stop endless loop sets the flag to break out of the continuous coroutine. All 3 also get a context menu entry and a button attribute if you have Odin, so you can test them directly from the inspector during play mode. You can access entries marked with context menu by right-clicking on the header of a component in the inspector. If you have Odin installed, the button attribute will put a button to click onto the component. Again, if you don't use Odin, don't use the button attribute. Next is the flip handling. Start flip does a quick check first. If we are already showing the requested side and not currently mid-flip, there is nothing to do and we return. Otherwise, we stop any currently running flip coroutine and start a new one. If we don't do this, things will jam up and lead to unexpected results. The flip coroutine itself is where the actual animation happens, and it is a 2-part process. First, we collapse the card down to a scale of 0 on the flip axis we defined. The duration of this first half is proportional to the current scale, so if a flip gets interrupted halfway through, the next flip won't awkwardly take the full duration to finish collapsing. It just picks up from where it is. Once the scale hits 0, we swap which side is active. This is the moment the card actually turns. The player can't see it because the card has no width at this point, so the swap is invisible. Then we expand back to a scale of 1 and we're done. We invoke the appropriate event depending on which side is showing, and then on-flip complete regardless. The continuous flip coroutine is a while loop that keeps going until the stop endless loop flag gets set. It waits for any current flip to finish, triggers a flip to the opposite side, waits for that to finish, and then waits for the delay before doing it all again. Now the pointer interaction methods, and this is where the interaction type and flip behavior settings from the inspector actually come into play. This part reads a bit verbose, I agree, but since this is something you'll do just once, I'm okay with this. Instead of manually entering the names of each method, you can click on your interfaces and choose Implement Missing Members, which will add all of them at once for you to fill out. Every single one starts with a check for if the object should be interactable, and if not, returns early. OnPointerEnter checks if we are set to hover interaction, in which we save the current side and then flip to face up. If it is hover continuous, we start the loop instead. OnPointerExit reverses that. For hover, we flip back to whatever side was showing before, and for hover continuous, we stop the loop. OnPointerDown and OnPointerUp handle the pointer hold interaction type. Down flips face up flips face down. Simple. And now that I read this, rather confusing. But it makes more sense in the code. OnPointerClick checks a helper method before doing anything. IsCorrectButton makes sure the right mouse button was used. If either check fails, we return. If we are mid-flip, we also return, because we don't want clicks stacking up. Then we switch on the flip-click behavior. Switch flips to the opposite side, to A always goes to face up, and to B always goes to face down. This is also the group where you might want to add things like setting new animation curves from outside via method, changing the animation duration, access to switch between, and more. Make this your own by adding whatever functionality you'd like to have from outside. Finally, we have 4 short helpers at the bottom. Opposite just returns the other card side, which is very small, but it makes the code a whole lot more readable than writing the ternary out every time. It checks the side, and if it is up, returns down. If it is down, it returns up instead. setScale updates both the private current scale tracker and the actual local scale of the transform, only touching the axis that matches the chosen flip direction. IsCorrectButton checks the event data.button against what we defined as the interaction mouse button. For example, checks if we pressed left when the button was defined as left. Save this and head over to the inspector again to attach the script to the main card container. You will have to assign your front and back manually in the inspector, but everything else is ready to start. Enter play mode and experiment. You can customize how your flip scales by changing the animation curve. By right-clicking on the curve, adding a new key point and dragging it up, you'll create a bit of an overshoot, for example, which makes the cards feel a bit bouncy. Just make sure that whatever curve you choose, it starts low and ends high. If you enjoyed this video so far, consider subscribing and giving it a like. To round the system off, let's add a controller to reveal multiple cards in order. I'll create a few duplicates of my cards for this, then head back to Rider for even more code. This is its own class, and it will work across juice effects in this plan series. Again, if you want to see more, please let me know and feel free to wish for a specific kind of juice effect too. This class is called Juicy Sequencer. It once again starts with an enum for the spacing mode. We'll either set a time and have the script calculate how to space out the animation based on child objects, or define the delay between each effect, or simply set it to instant to trigger them all at once. ShowIf is another one of Odin's handy attributes, and will make sure we only have to deal with either the total duration or the delay between effects entry based on what we set as the spacing mode. This system is coroutine based again, so we'll define one and its wait for seconds at the top, together with a value to hold the previous wait duration. This onValidate is a bit of an odd darkling, but a needed one. If we drag in a group of objects to fill the list will populate itself with the first mono behavior it finds on those objects, which, in my case, would be the image, not the juicy flip script. This onValidate gets called whenever there is a change in the inspector, runs through everything dragged into the list, and searches for the correct component by grabbing the isJuicy interface. Of course, there are two other scripts that handle this a lot more gracefully at runtime. ResetList clears it of all its contents, addJuicyEffect adds it to the list, but it needs to be cast to a mono behavior to function. Not as round as I enjoy things to be, so if you have a better idea, please share it in the comments. Trigger sequence can either be called from the context menu, the button, or from any other script outside, and will only do anything if there are children assigned to it. If we want to display everything at once, it will call trigger instantly and stop there. Otherwise, it calculates the delay based on which spacing mode we used, then checks if the delay matches the previously calculated wait duration. If it is different, we assign a new wait for seconds and store the new value. Really, this is mainly used for testing, where you want to switch between either of the modes while still in play mode. If you don't plan on switching at runtime, you can move the calculation and assignment without any need for the if check of the previous wait duration to awake instead. Stop sequence does just that. Sequence coroutine goes over each entry in the list. We can't assign interfaces directly, which is a major bummer, so we'll go with a list of mono behaviors instead, and check for each entry if the effect is an isJuicy inheriting mono behavior. If it is, we trigger the effect and wait for the specified duration before continuing. At the end, we free up our routine again. Trigger instantly instead does the same without any kind of waiting needed. Lastly, in onDisable, we stop any sequence still playing to make sure nothing shouts at us in the console window. Save this and head back over to Unity. You can attach the script everywhere, but the parent container for the effects you want to control makes the most sense of this. Add the game objects you want to control to the list, and yes, you can add really any kind of mono behavior game object to this list, but only the scripts that contain the isJuicy interface will be triggered. Head over to the play mode and give this another test. Did you enjoy this? Head over to the comments and let me know. If you want to learn more about Unity UI in particular, maybe consider subscribing too. Have a great week!